Now in last lecture, you see half adder and full adder. Now half adder is nothing but your addition of two binary bits, and full adder is nothing but two bits plus a carry in. And after adding this, we get a sum and carry out. Now like same half adder and full adder, see the half subtractor and full subtractor. So first we see the half subtractor. Now in half subtractor, we use or a half subtractor is used for the subtraction of two binary numbers. It is used for purpose of subtracting two single bit binary numbers. It contains two input and two outputs. Again, two input is nothing but your A and B as an input, and the two output is a difference and borrow of that two input. So see the block diagram for half adder, half subtractor. A and B are the two inputs, and the output is a difference and a borrow. This is your block diagram for a half subtractor. Now the truth table for half subtractor is again two variables A and B, and after subtracting these two A minus B, we get a difference and borrow. So the combination of A and B is 0, 0. So 0 minus 0, difference is 0 and borrow is 0. 0, 1. So 0 minus 1, difference is 1 and borrow is 1. 1, 0, difference is 1 and borrow is 0. 1 minus 1, difference 0 and borrow 0. By using this truth table, you can design a K-map for the difference and for the borrow separately. So it's again two variable K-map. A and B are the two variables. So A, it may be 0, maybe 1, B 0 and 1. So put this difference value in that K-map. So for 0, 0, it's a 0. For 0, 1, difference is 1. For 1, 0, difference is 1. And for 1, 1, difference is 0. Now solve this 1 and this 1 separately. So after solving this, we get A bar B plus A B bar. So this is nothing but your XOR gate, like your addition. And for borrow, draw the K map A and B. Again put 0, 1, 0, 1 here. And for 0, 0, so borrow is 0. For 0, 1, borrow is 1. For 1, 0, borrow is 0. And for 1, 1, borrow is 0. And now solve this K map for that 1. So this one is nothing but your A bar B. Now by using these two equations, you can draw the logic diagram for that half subtractor. Again, two variables A and B. And for difference, we require this XOR gate. So by the output of that XOR gate is difference. This is nothing but your A XOR B. And the borrow is A bar B. So A bar, this is your A bar into B. So this is a simple half subtractor logic diagram, truth table and a K map. Now the limitation of half subtractor is half subtractor do not take into account of borrow in from the previous circuit. Like your addition, carry in is not account in the half adder. So in half subtractor do not take an account of borrow in the previous circuit. So this is because the real-time scenario involves subtracting the multiple number of a bit which cannot be accomplished using a half subtractor. So if you want to multiple bit subtraction, we can't use this half subtractor. So to overcome this drawback, full subtractor comes into the play. So full subtractor. So full subtractor is a combinational logic circuit. It is used for the purpose of subtracting two single bit number and a borrow bit. Borrow in occur in the previous bit. It also take into consideration of borrow of the lower significant stage. Thus full subtractor has the ability to perform the subtraction of 3 bits. So 3 bit is nothing but your A, B and borrow in bit. So full subtractor contains 3 inputs and 2 output. Again 2 output is your difference and borrow. So this is a simple block diagram for full subtractor. A, B and borrow in is the input, and after subtracting this we get difference and borrow. Now the truth table for that 3-bit full subtractor is A, B, B in are the 3 input and difference and borrow out. These are the 2 outputs. 0, 0, 0 is the difference is 0, borrow out is 0, 0, 0, 1. So again 0 minus 0 is a 0, and the 0 minus 1 difference 1 and borrow out 1. 0, 1, 0. So difference is 1 and borrow out is 1. 0, 1, 1. Again difference 0 and borrow out 1. 1, 0, 0. So difference is 1, borrow out 0. 1, 0, 1. Difference 0 and borrow out 0. 1, 1, 0. So difference 0, borrow out 0. 1, 1, 1. Again 1 minus 1 is a 0, and this 0 minus 1 is the difference 1 and borrow out 1. So draw the K-map for that difference separately and draw the K-map for the borrow out separately. So see, this is a K-map for difference. So after solving this, we get A XOR B XOR B in. So the equation for that borrow in is A bar, B bar, B in. So after solving this all 1, we get a difference equal to A XOR B XOR B in. And now for borrow out, so A, B, B in, again 3 input, put this 0, 0, 0, 0, 1, 1, 1, 1, 0, put the value of borrow out. So these are the values. Now make a pair of the adjacent one, one pair, 2 pair and 3rd pair. Solve 3 pairs separately so that we get a borrow out equal to A bar B plus A bar B in plus B B in. And now draw the logic diagram for that equation. So this is your A XOR B XOR B in. So A XOR B XOR B in. This is your XOR gate required, and 3 inputs. A, B, B in are the 3 inputs. So we get a difference here. And for that A bar B, this is your A bar into B. A bar B in. So A bar into B in and B B in. So B into B in. And for plus sign we require OR gate. So A bar B in or A bar B in or B B in. So we get a borrow from that equation. So this is nothing but your K-map logic equation. After solving this K-map, we solve this equation in the next slide. And this is your logic diagram by using this logic equation. So see here, A, B, B in, this is your K-map. And now for that 0, for that one 0, 0, 1, so 0 is A bar, B bar, B in. For that one plus A bar, B, B in bar. For that one A, B bar, B in bar, and for that one A, B, B in. So solve this equation. From that 2 equation, we get a B in common. From that 2 equation, we get a B in common. See here, from that 2 equation, we get a B in common. So A bar, B bar plus AB. plus from that two equation we get a b in bar common, so we get a bar b plus a b bar, and this is nothing but your x or XNOR gate. So we can write here b in XNOR, a XNOR b plus b in bar a, this is your XOR gate, so we write here a XOR b. Now again consider b in bar equal to a and b equal to a XOR b here. Put this value in that equation. So b in is your a and a XOR b is your b, and this is b into this b bar plus again b in is a, so a, this bar is here and a. So this is nothing but your XOR gate. So we can write here a XOR b for that equation and put this value in the equation. So a is your b in and b is your a XOR b. So a XOR b XOR b in. This is the final equation for that difference. Now you can also design full subtractor using a half subtractor. This is a block diagram. Two half subtractor, again two input a b, and same we design by using a full adder, full adder using a two half adder. So we use here same logic, a minus b, we get some difference here. Use this difference as a first input of a second half subtractor and borrow in. So we get a final difference from the two equation, two half adder here, and this difference, and this borrow and this borrow, we add this two borrow, we get a borrow out. Now design the full subtractor using a half subtractor. So this is nothing but your half subtractor, first half subtractor, and we use one more half subtractor here, see here half subtractor, and the output of first half subtractor difference is used as a first input of a second half subtractor, and connect borrow in to the first second input of a second half subtractor. So this is your b in. So we get a difference here, and this borrow out and this borrow out, so we get a final borrow out. And if you solve this equation by using this logic diagram, so we get a XOR b here. So difference is a XOR b and this b in available here. So we get a XOR b in. Now from that equation we get a bar b output. So we apply here this output a bar b, and the output of that equation is a XOR b. So from that NOT gate we use this NOT equation and into b in. Which b in? This b in is available here. So b in. So after solving this equation by using this logic diagram, we get a bar b, this a bar b, and this is your XOR gate. So we use here plus sign plus a XNOR b, this XNOR b into b in. So if you solve this equation, we get a bar b plus a bar b in plus b in. So we try to solve this equation. How to solve this equation in the next slide? A bar b plus a XNOR b in. So we can write here a bar b plus a bar b bar plus a b. This is your XNOR gate into b in. So a bar b plus a bar b bar, this b in plus a b in. So multiply this by using a 1 plus b in, because 1 plus b in is nothing but your 1. This is a OR equation. 1 plus a is 1. So a bar b plus a bar b in plus a bar b in plus a b in. So A bar B in and B in common from that two equation. From that two equation, so we get B in into A plus A bar plus A bar B in. So plus A bar is nothing but here 1. So A bar B plus B in plus A bar B in. Again multiply this A bar B by 1 plus B in. Again 1 plus B in is your 1. So A bar B plus A bar B in plus B in plus A bar B in. Now take A bar B common, A bar B in common, A bar B in common from that two equation. So we get B plus B bar, and again B plus B bar is your 1. So the final output is A bar B plus A bar B in, and this is your 1 plus B in. So this is your final equation. So this is nothing but your half subtractor and full subtractor. If you really like my video, subscribe my channel Digital Electronics. Thank you for watching my video. Stay tuned with my video. Thank you.